Hey guys, Mr. Milton here. Today we're going to look at triangle congruence by angle, side angle, and angle, angle, side notes. At the end of this video, you should be able to identify ASA and AAS congruence between two triangles. And you should be able to prove two triangles are congruent using any of the shortcuts learned: side, 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 angle, and angle, angle, side. Okay, so in yesterday's notes, we learned two shortcuts to proving triangles are congruent, and those shortcuts were side, side, side postulate and the side angle side postulate. Today, we will learn about two more shortcuts. Okay, so here naming an angle, side angle postulate. If two angles and the included side of a triangle are congruent to two angles and the included side of another triangle, sorry for the bad L. Okay, then the triangles are congruent. So here it says, name the two triangles that are congruent by angle, side angle. So here we're making sure that looking at our markings, that we're not saying, hey, there's two angles marked and the side marked. We're looking for two angles and an included side. So here, when we look at the different triangles, just like included angles, remember that our included angles for side angle side were marked between the two sides that were marked, right? When we talk about an included side, it's going to be the side in between the angles that are marked. And so here we see angles marked, angle C and angle A marked, and the included angle is CA. Okay, here we see G and D marked, and the included side GD. Here we see N and I marked. The included side here would be an I, but here they circle in or mark in F, and so it's not including this one right here. So the two triangles that are congruent to each other are these two triangles. Now remember that when we name them, we need to still make sure that we pay attention to put their corresponding parts in the correct spot. Okay, and I always use a pattern to help me do that. So I'm going to go from one arc, two arcs, no arcs. So triangle cat, makes up cat. Okay. And here, you'd be tempted to call it triangle dog because, I don't know, that'd be kind of cute, nifty, something like that. But we need to go one arc, two arcs, no arcs. That's how we named the first one. So GDO. So yeah, not as cool as cat is congruent to dog, but it is mathematically correct. Okay. Second shortcut that we're going to learn today is angle, angle, side theorem. And it says, if two angles and a non-included side and that's a U, are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. Okay. So how many included sides do two angles have? So if we look at it, how many included sides do two angles have? Well, anytime that you have two angles marked, there's only one included side that can be used, right? This is the only included side. Okay, it has to be in between them. There's these two sides that would not be included. Okay, so how many included sides do two angles have? Well, it's only one. How many non-included sides do two angles have? Well, like we said, there are two. There are two sides that would not be included. Okay. So here we go. Let's look at this problem. It says explain or answer the question using the diagram below. So how do we know that angle PQT is congruent to angle SQR? So PQT would be here. I'm going to mark it with two arcs. SQR right here. I'm going to mark it with two arcs. How do we know that those two are congruent? Well, these are vertical angles. Okay, vertical angles are congruent. That's how I know. So with that, it says which sides would need to be congruent to have angle side angle congruency. Okay, so important that they're asking us about angle side angle congruency. that side here is the included side, kind of a hint in the name that it's between the two angles. Because in the triangle, it'll be between the two angles. So which sides would need to be congruent to have angle side angle? Well, for that one, we would need the included sides, which would be PQ and QS. And SQ. Okay. Yeah, I said it right. Okay, that's what we would need for angle side angle. Next it says which sides would need to be congruent to have angle side congruence. Okay, let's go erase this marking so I can see a little easier. Okay, so remember for angle side, we would not want included angles here, right? Or an included side. So you could say that, hey, maybe PT was congruent to, I don't know, RS. PT could be congruent to RS, or, right, so let me just use a different color, so, or TQ could be congruent to RQ. Okay, and you'll notice that there's two options here, just like we said, there's two not included sides. So down here at the bottom it says, notice which letter combination is not a congruence theorem. So as we look at all four of our congruence theorems, we got side, 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 we've got side, side, we've got angle, side, and we have angle, side, angle. We do not have, because I'm going to do this in the correct order, we do not have SSA. It is not a congruence theorem. Okay, that is not a way that we're going to prove that two triangles are congruent. Okay, we also don't have AAA. We'll look at that later, but we don't have AAA either. Okay, but we don't have SSA. That's the one that we're really pointing out here. Let's go through some proofs here. All right, so here it says, and these numbers here at the difficulty level is a little arbitrary. Here it says, given that Q is the midpoint of PS, prove that PTQ is congruent to SRQ, or sorry, triangle PTQ is congruent to triangle SRQ. So I'm going to use red to mark my thing up and blue to write my proof. So as I look at this, I'm going to think through, okay, Q is the midpoint of PS. And one strategy that I have that you can follow is, hey, let's mark our diagrams up, kind of talk through or think through it, and then write our proof and make sure that we have reasoning for everything. So here it says Q is the midpoint of PS. So I'm thinking, okay, Q is in the middle of PS. That must mean that this is equal to that, right? And let's do a different color so I can see a little bit more easily what I'm doing. Okay, we're doing that because Q is the midpoint, and midpoint means that it cuts it in half. Okay, and the other thing that we see is that PQT and RQS are vertical angles. And so those should be equal to each other because vertical angles are congruent to each other. And so now I should see that I have angle side angle. Okay, so now that I've thought that through, I'm going to go through and write my proof. Okay, so it kind of taken for granted that angle P is congruent to angle S. And we took that for granted because it was given to us. Okay, given to us in the diagram, right? The other given information to us was that Q is the midpoint of PS. But remember that this alone didn't give us a congruence. Like it didn't say like one thing is equal to another. So we need to build off of it. We already did that in our diagram, but we need to make sure we do it here. Since Q is the midpoint of PS, we know that PQ is congruent to SQ. And we know that because that's what midpoints do. That's kind of how we explain it to ourselves. And so we'll say definition of midpoint. Okay, and now we got to say that two things are congruent to each other. So it's kind of like our mark, like, hey, we can be done with this. Okay, and then finally, we were able to say that angle PQT was congruent to angle SQR. And that was because vertical angles are congruent. I'll just write vertical angles there. And now with those three things, we had the shortcut, and we were able to say, okay, these two triangles, triangle PTQ, was congruent or is congruent to triangle SRQ. And it's congruent because angle, side, angle. The side is included between the two angles. Okay. Number 3 tells us that RN bisects angle MNP, and that angle M and angle P are congruent. So as I look at this, I'm like, okay, angle M and angle P are congruent. And I'm just going to mark that. RN bisects MNP. So the angle MNP is this angle here, right? Bisects just means cuts in half. And so since it cuts in half, we should know that these two are equal to each other. Okay. All right. So from there then, I'm looking at that, and I say, oh, wait a second, NR is a part of both of these triangles, right? And so it's really equal to itself by the reflexive property. And so I have angle, side, angle, side, not included. And so that should be enough for me to say that these two triangles are the same. So I've gone through that proof in my mind, and now I have to write it out. So my given angle M is congruent to angle P. Given. Also given is that RN bisects angle MNP. Given. Okay, so we're done with our given information. That's, again, information we didn't have to think about or do. They just told us. And so from there, because RN bisects MNP, we can say, well, MNR, and again, I have to say angle MNR, is congruent to angle PNR. And we're going to say, because that's what a bisector does. A bisector cuts an angle in half. And so we'll say definition of angle bisector. Okay. So again, so I'm marking like that I have two things congruent. Okay. And then we were able to recognize that NR was a part of both triangles. So NR is congruent to NR. You can make those markings. Oops, that's not 5, 4. And that is because of the reflexive property. And so now I said that three things were congruent. I can check to make sure it fits into one of my shortcuts, and it does. And so triangle MNR is congruent to triangle PNR because of angle, side. And again, this side is a non-included side. And so that's why we use angle, side, and not angle, side, angle. Okay, oops, went down too far, sorry guys. Last proof here. Here, they ask us to prove that triangle FGJ is congruent to triangle HJG. So as we go through and walk through this proof for ourselves really quick, notice the given angle F and H congruent to each other. Okay, and then we also notice these parallel lines. Okay, with parallel lines, there's only a couple things that we really should be looking for. Remember, we talked about corresponding angles, alternate interior angles, and same side interior angles. Okay, but things that I would hope would like raise a flag in your mind is, wait a second, corresponding angles and alternate interior angles are congruent. Here we're looking for things that are congruent, so those are probably the two most common pairs we're looking for. So as I look at my parallel lines, I notice GJ is a transversal, okay? And so here, corners of these Z's or N's, these angles are alternate interior angles. So they're congruent to each other, okay? And now as I look at these two triangles, FGJ and HJG, say, wait a second, they both have this side GJ. And so I'm going to say those are equal. And I have angle, side, angle, angle, side. Okay, again, angle, angle, side, because the side is a non-included side. And so that should be enough for me to say the two triangles are congruent. So now I'm going to go through and write my proof. First given is that angle F is congruent to angle H. Again, that's given information because it was given to us in the diagram. Okay, this is an overlooked step, so I want to make sure we say it. We're going to say that FG is parallel to JH, or HJ. Say HJ. It really doesn't matter at this point, but I'm going to keep my congruence the same since I kind of know what it's going to be. Okay, and that's given. We did not have to find out that the lines are parallel. They told us with the arrows. Okay, now again, with this first one, we got to say two things were congruent. Here, we haven't said that something's congruent, so we're going to try to build off of it. How does this being parallel help us? And it helped us because we saw that since those are parallel, then angle FGJ was congruent to angle HJG. And we know that because of the alternate interior angles theorem. Okay. And so now we got to say two things are congruent. We can continue with some new information. From there, we were able to say that this segment was going to be congruent to itself because it's in both triangles. Now notice I'm going to name this GJ. I'm going to name the other one JG. Again, it's the same thing. So you could just say GJ is congruent to GJ if you'd like to. But because of the corresponding parts, I see that G has two arcs. And I started with that. And the next one, J has two arcs. So I'm going to start with that one. Kind of nitpicky, so I'm not going to probably be too hard on that. But just so you know, this should be probably the correct one just because we know what our congruent statement should look like about right now. And again, those are equal to each other because of the reflexive property. Okay, so we have three things marked. Should be enough for us to say that two things are congruent to each other. Make sure, angle, angle, side. And so we could say triangle FGJ is congruent to triangle HJG because of the angle, angle, side theorem. Okay, and so there we have it. That is our next two shortcuts of angle, angle, side, and angle, side, angle. All right, see ya.